Determine the transfer function C of S upon R of S for the figure shown below. It is a MIMO system, a multi-input, multi-output system. There are two systems. One is G1, another one is G2. Two inputs are there, X1 and X2. Two outputs are Y1, Y2, but they are cascaded. They are in parallel and they are interacting through this line. This line is interaction line. Any change in G1 will affect G2. Similarly, any change in Y2 will affect G1. That is called interaction. That is there. But the input to both systems are same. Here, input to the same systems are connected together. That's why same. The outputs are added together. Now we have to find, but it's difficult to find block diagram reduction method. But here the method is not mentioned. That's why let us find by using Mason's gain formula. This is node 1, node 2, node 3, node 4, node 5, node 6, node 7, node 8, node 9, node 10. 10 nodes are there. So we have to draw the signal flow graph. 1, 2, 3, 4, and this is 5. Then this is 6. This is 7, 8, 9, and 10. 10 is C of S. This is R of S is input. 1 is R of S. The gain between 1 and 2 is 1. Between 2 and 3 is again 1. Between 3 and 4, it is a negative input. That's why this is -1. Between 4 and 6, G1. Between 6 and 4, -1. Between 6 and 8, again 1. 8 and 9, 1. 9 to 10, 1. 2, 3 to 5, it is then input is not mentioned. What sign is not mentioned? Let us take it as positive. Therefore, this is +1. Then this is G2. 7 to 5 is -1. -1. 6 to 5 is -1. 6 to 5 is -1. 7 to 4 is +1. 7 to 4 is +1 because of the input is plus here. The input is plus. That's all about signal flow graph. Now we have to find the transfer function. For that, the formula is T of S equal to 1 by delta sigma Pk delta K, where K is the number of forward paths. Here number of forward paths equal to 4. The one is G1. This is here -1, therefore minus G1. Second forward path is G2. Third forward path is minus G1, -1, then G2. This is third forward path. Fourth forward path is this way. This is +1. This is G2. This is G1. So number of forward paths equal to 4. Therefore, K equal to 4. Let us find the gains of forward path. P1 equal to minus G1. Delta 1 equal to part of graph which is not touching this forward path is this G2 -1 is part of graph which is not touching the forward path. Therefore, 1 plus G2. P2 equal to what? P2 equal to G2. and delta 2 equal to the part of graph which is not touching the forward path is G1 minus 1, therefore 1 plus G1. P3 equal to what? Minus G1 minus 1 G2. Therefore, G1 G2. Delta 3 equal to 1. No loop which is not touching the forward path. P4 also G1 G2. G1 G2. Delta 4 equal to 1. Now we have to find delta. Delta equal to 1 minus the loops. The first loop is G1 minus 1. This is L1. This is L1. Second loop is G2 minus 1. That is second loop. Third loop is minus G1 minus 1 plus G1 minus 1. Then G2 plus 1. So it is minus G1 G2. Third loop. Fourth loop L4 is this way. L4 is G1 and one more loop I missed here. This is the one more loop. Feedback. This feedback. So G1 and at 9 it comes to 2. This is 3. So G1 minus 1. Therefore, this is L4 is minus G1. L5 is there. L5 is, it comes like this. G2, again from 9 to minus 1. This is minus G2, minus G2. I think one more loop is there. L5 L5 is 1, 2, 3, 4, 5 so far. This is L5. L6 we have to find. L6 is it starts from here G1, then G1 minus 1, then G2, it goes to 9, then it comes to 2. This is 2, this is 3. This is one loop. Minus G1, G2. Minus G1, G2. This is also minus. Minus, 3 minus are there, or minus G1, G2. L7, it starts at 2. It goes to minus G2, then it goes to G1. This is plus 1. Then G1. It comes to 9. It comes to 9. Then feedback to 2. This is G2. G2 is plus, then G1 also plus, G1, G2 minus G1, G2. This is also G1 is minus. That's why plus G1, G2. Plus G1, G2. That's all. 7 loops. That's why that is before writing that, let us write L1 equal to what? L1 equal to minus G1. L2 equal to minus G2. L3 equal to minus G1, G2. Minus G1, G2. L4 equal to minus G1. L5 equal to minus G2. This is plus G1. Plus G1 because G1 is minus. This is minus. That's why plus G1. Minus G1, G2. L7 equal to minus G1, G2. L1, L2 are not touching each other. Therefore, G1, G2. L1 and what is that? L5 are not touching each other. L1 and L5. L5 equal to what? Minus G2. L1 is minus G1. Therefore, L1, L5 equal to G1, G2 again. L4, L2 and L4 are not touching each other. L4. L4 is plus G1. L2 is minus. Therefore, minus G1, G2. Only 3 non-touching loops. 2 non-touching loops. That's all. Therefore, delta equal to 1 minus minus G1 minus G2 minus G1 G2 plus G1 minus G1 G2 L3 L4 is plus G1 L5 is minus G2 L6 is minus G1 G2 L7 is minus G1 G2. Now G1 getting cancelled. Therefore, the two non-touching loops we have to write. That is plus L1, L2 is G1, G2 plus again G1, G2 minus G1, G2. L1, L2, L4. L2, L4 is G1, G2. That's all. Therefore, these two getting cancelled. These two getting cancelled. Therefore, the overall transfer function is numerator is minus G1, 1 plus G2 plus G2, 1 plus G1 plus G1, G2 plus G1, G2 plus G1, G2. That's all. Denominator 1, delta equal to 1, G1, G2, 2 G2s are there. Therefore, 1 plus 2 G2, 4 G1, G2. That's all. The numerator becomes, numerator is minus G1, minus G1, minus G1, G2, plus G2, plus G1, G2, plus G1, G2, plus G1, G2, whole divided by 1 plus 2 G2 plus 4 G1, G2. That is equal to numerator, these two getting cancelled. Therefore, minus G1 plus G2 plus 2 times G1, G2 whole divided by 1 plus 2 G2 plus 4 G1, G2. That's all.